Welcome back. So our final lesson in the linear review unit is going to be on linear regression, and we're going to be using one of these bad boys, TI-80. I'm going to be using an 84. I'm going to be using my emulator on the screen though. But these are the calculators that we have in our classroom. These are the color screen, the CEs, and they're beautiful, and I love them. And I want one for my birthday. But hint, hint. Um, we can use an 83. We can even go back and use an 82. The problem is the way the menus are set up now are a little different than the older models. So even if you're using like a regular 84 versus an 84 plus, or if you're going back and using an 83, you just have to remember that some of the menus that I show you are not going to look exactly the same. Just like every other, technology developer, Texas Instruments gets feedback from their users and they look and try to streamline processes or add extra options when you're going through menus that's a little more user friendly. So be a little flexible with it. And if you're having a tough time using your graphing calculator, they're not from me, but there are tons of YouTube videos out there on how to fix problems that you're having with your calculator. I remember having one with one of my students' calculators, and I had no idea what they did to it. So I just went into YouTube and I looked up, how do you fix whatever it was, and like 12 videos popped up with some awesome person out there doing exactly that and fixing my problem for me. So it was great. So yay, YouTube. All right, so first we got to talk about correlation and linear modeling. So linear indicates that we want our models to look like lines, and we know from real world information that it's very rarely pretty enough to look exactly like a line. So first thing we have to talk about is determining whether they have correlation or not. So a correlation of a line indicates how close the data points are to being linear. And there's a way that we calculate correlation, which when you take a prob in stats course, you will hand calculate correlation. It's a hoot. But we're going to be using our calculator it's going to pop out the correlation value. So right now, it's all our job is to be able to look at it graphically and go, ooh, bad correlation. Or sometimes we're going to look at the calculator who will calculate the correlation coefficient for us. And it's our job to interpret that information, because isn't that the whole point of humans working, is to take often technological or computer-based answers and interpret them. So we know what to tell the other humans, because guess what? Most people out there don't like to talk about math. All right, so this first example here, we have what's pretty, not exactly a line, but pretty close. This is a good correlation. It's going to have a positive correlation coefficient because the slope is positive. But if I look at this one next to it, figure 1,5b, wow, awful. Like maybe if you squint, it kind of looks like a positive-ish correlation. So it turns out this is really poor correlation. So if you're trying to prove to somebody that you could create a linear model with this information, hopefully that person knows enough about math to say, no, you cannot. So turns out that's not, either the data has no correlation or it's linear is not appropriate. So the correlation coefficient, don't know why, but we call it R. I think it has to do with the term regression, but I don't know. Google it. Is the same sign as the slope of the line for the least squares regression line. So when R is negative, you're going to see something that has a negative slope. And when R is positive, you'll see something with a positive slope. And it has to do with whether one variable increases as the other increases. You know how slope works. Okay, so it has blah, blah, blah. If there's no correlation, R is going to be really close to 0. So the idea is, think of the correlation coefficient almost as a percentage. The closer to 0 it is, that's like 0%. And then like 0.99 means 99%. That's how I always interpret it. It's not exactly how it works, but it's how my brain works. So that's all that matters, right? So these examples here, someone has already calculated the correlation coefficient for us, and they actually kind of sketched in a shadow of the linear regression line that would go through the data points. If you notice here, all these little dots are the data points, and this is the equation that they came up with either by hand or using technology. And I noticed the correlation coefficient is 0.7. Like, that's clearly positive, and I do see a positive slope line. And if I squint, and I kind of look at all these data points, I do kind of see a linear relationship. Like they are increasing, actually are increasing as the y's are increasing, but not necessarily close together, forming a nice line. So that's why like 70% is the way my brain interprets that. Like that's not a real strong correlation. I mean, it's not the worst we're going to see, but it's not great. This one came up with 0.3. In the words of my 7-year-old child, that is an epic fail. We would not say that this is linear this does not have good linear correlation. So I would not be able to use my linear model that I came up with. Or if I chose to use it, then I hope I'm made fun of for the rest of my life. All right, in here, there is no correlation whatsoever. So definitely, if you kind of forget that line, just squint and look at these points like a cloud. No, it's not great. But here, you notice the difference. They're just as kind of spaced out as this original example here, but now it's a negative 0.7 correlation coefficient, which means still not awesome correlation, but I do notice there's a definite negative trend. So that's what we're seeing here. I think there's a typo on this one. It's supposed to be negative 0.3, maybe. I'm not real sure. Maybe not. And 0. So these are some examples of what I would consider not great correlation. So the next question you probably have floating around in your head is like, okay, so like what's good? Think of it as like, I know this is a different answer for everybody, but like what grade would you want on a test? I'd want an A. So anything in the A range for percentages would make me happy as far as correlation. And it also depends on what you're using information for. If you were a statistician and you were trying to create a model and prove that your model was viable, 0.7 correlation coefficient is not going to do it. So keep that in mind. So this, I don't think these are on your papers here, but, oops, spoiler alert, I should have moved that. This correlation coefficient they're claiming is negative 0.9. So if we were in class right now, I'd probably have you guys shout out some guesses to me and see what you think. This is not on your sheet, like I said. So this next one, ooh, look at that, negative 0.5. Bad. All right, it's not bad because it's negative. It's bad because it's 0.5, which is bad score. 0, no correlation. No. All right, this one I can clearly tell these next three are positive-ish. Positive 0.5, awesome. Let me guess. This one's positive point. Well, I was going to say 9, but maybe not. Let's find out. Oh man, look at that next one. That's what you want to see with linear regression. If I could draw a straight line, I could almost draw a straight line to this point. I have a feeling this is, yeah, positive 1, perfect linear correlation. That probably won't happen in real life. 0.99 is like as best as you can hope for, but that's a really great linear correlation. Probably what happened is I had ordered pairs that I knew fell on a line, and then I plotted them on my calculator, and then there you go. So let's talk about how we use our calculator. I'm going to switch to my calculator screen. So hang with me. Remember, yours might not look exactly like mine. First thing we're going to do is we're going to take our information for the years and the cash flow per share. We're going to put it into the graphing calculator. And time starts in this problem in 1988. So what we're going to do, because I don't want to type 1988 in my calculator because that makes for a gross line. I'm going to call this year 0. And then 89 would be 1 year later. And 2, and 3, and 4. Now, don't just assume it's 0, 1, 2, 3, 4, on every table you see. Because sometimes they jump over like 2 years and then 5 years later. So you have to be careful that, you can count. So we're going to go to our calculator and we're going to enter our data. So get out of there. All right. So right here it says stat. So go to your stat menu, wherever that is. And then we're going to edit our list. So under the edit menu, choose edit, which is the first option. And then I don't have anything in my list right now, but if you did, which in PreCalc you very likely will, if you go to the name of the list, L1, and be careful here, hit clear, and then scroll back down, it will delete whatever was inside the list. Now you have to hit clear to do that because you're clearing out the data values. If you hit delete, you're going to delete the entire list one. So I'll show you what that looks like. I'll mess up on purpose. It's good, right? Delete. And then I go, where'd my list go? So let's say you deleted list 1 and you need it back. You can insert a list. So see where it says INS? So it insert. And then list 1, you can find a couple places, but right above the 1 key done in blue is L1. So call it list 1, if that's what you want to call it. If you do. And then voila, it's back. So I will tell you that if you already had something in your old list 1, it'll have a memory of that and it'll put it back in. It's like an undo key, essentially. All right, so anyways, I digress. List 1, I'm going to put all those X values in, which remember were 0, 1, 2, 3, 4. I wish it was like Excel where you could just like autofill, but to my knowledge, I can't. So 0, enter, 1, enter. I wonder if I do this. 2, enter. 3, enter. 4, enter. and then go over to list 2 and enter the data values exactly as they exist from your table. So 2.38. Jeepers creepers. 2.38. Enter. 2.79. Usually I have to slow myself down because I talk and write too fast, but man, am I slow today. All right, 3.64. 4.06. And then before I do all this work, I want to make sure I double check my entries. You know me. All right. So the next thing we have to do is if I want actual information from my calculator here, I need to instruct it to give me the correct information. So I have to do what's called turning my diagnostics on. There's a couple different ways to do it from what I hear, but the way I always do it is I go to my catalog, which is second 0. And then this is an alphabetical listing of every single command in your calculator. Is big. Diagnostics on is what we're looking for. So you could scroll for a while, or you could have it jump to the D's by doing alpha and then D, which is right there, the inverse key. Oh, or not. Oh, for Pete's sake. Alpha. Here we go. All right, and then we scroll down. Let's see here, down where it says diagnostics on. There we go. Oops. My scrolling has a delay. Okay. On. And then hit enter. And then hit enter one more time. And then they're on. So unfortunately, every time you reset your memory and stuff, that you might have to turn this on every time. Okay, so now go to stat. And then we're going to go to, this time, calc. Like a sub menu called the calculate menu, and we're going to be doing what's called linear regression. So you have two choices, ax plus b or a plus bx. I always go with ax plus b because that kind of flows naturally for what I've already learned for linear lines. So 4, and then for my newer calculators, it pops up a secondary menu, and it says, is this where you want to get all your information? Because sometimes we get really into this, and we enter like list 1, list 2, list 3, list 4, list 5, list 6, and you get like data everywhere. You want like list 1 and then list 6. So on the old calculators, it always assumes you want list 1, list 2, unless you tell it otherwise. It's going to default to that here on our newer calculator. Frequency list, we are not going to be using that this time, but that's if you have like a frequency table where you have multiple entries, like 6 showed up 25 times, so you would have another list where it has the frequency of every entry. We don't have that. If you want to store your regression equation somewhere, you totally could. I don't think I want to. And then we're just going to go down to calculate for us. Then enter. Okay, so here's all the information we wanted. So it says y equals ax plus b is the form. And then it says a is 0.421, b is 2.378, and then r squared and r are your correlation coefficient values. So you want the r, the very last one here that says 0.9999. So that is a good, strong, positive correlation. So I don't know what they wanted from here. What did they want? I want to sketch it. Ugh, I hate sketching these. All right, so, oh man, I'm gonna sketch all over my face if I do this. All right, so you sketch them. If this was homework, feel much better than I just did, and describe the correlation coefficient. It was very strong, so I wouldn't mind if you even put the word very there. Very strong, positive correlation. Next question says, let x equals 0 represent 1988. Write an equation of the line by hand. Oh, blah. I didn't do this yet. All right, so they want us to use 88 to 90, excuse me. 88 and 1990. So using these two ordered pairs, they want us to find the equation. So first we have to find slope, which remember we're using these two ordered pairs, but don't forget we use this as 0 and this was 2. So 3.23 minus 2.38 over 2 minus 0. I didn't do this yet. You know me in decimals, it's not going to happen. Don't judge. 0.85 divided by 2, 0.425. is my slope. And then my y-intercept, if we start at 0 here, it would be 2.38. So for me, by hand, the line is y equals 0.425 x plus 2.38. And I don't have it up anymore, and I didn't write it down. But the calculator's equation that it came up with for the whole data set was 0.421, 2.38. Oh man, that was pretty close. So the calculator came up with 0.421 plus 2.38-ish, I rounded. So man, that's why we had such a strong positive correlation there. If we started calculating the slope between all the different points and kind of compared them to that green one I just wrote down, we'd find that those lines were super close. And the way you hand calculate regression is kind of a tedious process, but totally could do it. We're not going to. All right, so there's a little note about your old calculators. If you need to pause this video right now and kind of check this out with your old calculator, go ahead. But the future is now, people. Start looking at your new calculators. All right. Oh, by the way, you can get a calculator on your computer. You can get like an emulator like I have. I have a super fancy one though, thanks to our distributor for our calculator, but you can get a less fancy emulator. I have gone to, I don't know if it still exists, so sorry if it's a lie, but I look up what's called the Wabbit, like a rascally Wabbit, emu. And my students have had a lot of luck with getting a cell phone app calculator that looks exactly like our graphing calculators. It's usually the older model and not the color screen, but you know, whatever. All right, so finding line of best fit. We already did that. Yeah, we kind of already did all this. Sorry, I jumped the gun. Remember we had that equation written down on the other screen, the 0.421 x plus 2.38, I think it rounded to. And the correlation coefficient was like super duper duper strong, 0.999 something. Skip it a little bit there. This is all very interesting information. If you need to kind of stop and look at the screen in more detail, these are the places where, like I said, you can go to YouTube and find ways to fix your calculator if it's not showing what you want it to show. But this is a good screen to look at. Okay, follow up. So our linear model was the page 421 x plus, and if I don't round 2.378, I'll get a more accurate answer, but you know, big figs and all that, I probably should round to the hundredth. Oh well. Talk to your science teacher about that. So remember, years start in 1988. So in the year 2000, that would be 12 years later. So using this formula and throwing a 12 into there, turns out that the price per share was $7.43-ish, because remember I rounded a little. And if I go to 2014, that would be when, that's 2 years later, no, not 2. So what is that? 26 years later from the original model, right? Turns out it's $13.32. Awesome. Okay. So that's great. Calculators are awesome, and I get frustrated when some of my students, and even when I was a student in college, you know, you go to college and take a stats course, and once in a while you get a professor who is just severely old school and doesn't want to ever use calculators for anything. And I'm not saying there's not a place for that. We should learn how to do everything by hand because you want to know how the calculator works. Someone had to program it, right? And maybe one day you'll be programming additional programs into your calculator. So we do want to do them by hand. We have some unique problems where you can't do them on the calculator, but you know, I hope you don't ever have a person who makes you do like 20 of these problems by hand every time with no confirmation of the technology whatsoever. That's a shame, right? All right, I'm going to get off my soapbox. I'm going to look at example 2. So if we don't have a calculator, this is what we have to do. We should draw the scatter plot. We're going to find the slope through some of the data points. So you have to select which 2 data points you want to choose. And that's usually based off of your scatter plot. So I'll be honest, I'm super tired right now. I'm not going to draw the scatter plot, but what would happen is I would plot the points and then I would kind of squint and connect a line through the points as best as I could. I'd use a ruler and everything, right? And then 2 points, hopefully I could find 2 points that actually go through, that line goes through, and I would use those two ordered pairs to find an equation by hand. Turns out, whoever did this problem said, please use x equals 4 and 8. So that would be this and this ordered pair. Well, they're convenient, aren't they? And then we can hand calculate the linear equation. And then if we were in a stats course and we were hand calculating correlation coefficient, we would have to do a whole lot of math. So I'm not going to make you do that right now. First, let's find slope. So slope is 8 minus 4 over 8 minus 4. Well, that's fun. Slope is 1. And then the equation, we're going to have to use point slope form at first. Y minus, pick your favorite point. So y minus, I don't know, I like 8. Equals 1 times x minus 8. So doing a little math here, we would distribute the 1, boring. We'd add the 8, comes out to 0. That's fun. Oops, why did I do that? All right, y equals x. There's my equation. And then pretend I plotted all those points. You better plot them. And then I'm going to graph the line y equals x through there. And then I want to know if it's a good model. And I don't know if you can see that. Totally did it. No. Eh. I don't know. Trust me, it's there somewhere. All right. So yes, it is a good model, and it's a good model because there's not a lot of distance between the ordered pairs and the line that I plotted. The other issue is I kind of look for if there's, some points that are above the line, some points that are below the line, and they're kind of like equidistant. That helps with a good correlation coefficient too. You shouldn't have like a bunch of points up top that are like way above the line and then like 1 underneath it, because that's going to mess up your correlation coefficient for sure. And the reason I know that is because I totally know how to hand calculate it. Sorry. The next problem is using our graphing calculator. Again, this is kind of fun because they're jerks and they set up the information in a chart and then they're like, and then the chart's going to be inverted. We're going to figure out in a second. But that's the good news about your technology. Like, it does not matter, right? So if I enter this data like every other high school student in America does, is they enter the first row into list 1 and the second row into list 2. So I'm going to pretend like I'm a 17-year-old and I'm going to, stop texting. And I'm going to enter my data exactly how it looks on the chart. I'm not even going to read the problem because, like, why would I read? That's not true. You guys are great readers. Stop it, Bruzo. You're awful. All right. So clear your list out. Do not delete. Just clear it. Okay. And then open the name, hit clear, get back down. There's other ways to clear your list. You can go to the memory and do it, but this is quicker for me. All right, and then if I enter the data exactly how it looks without reading the problem, I'm going to enter 3.8, 3.5, oh, 5, 3.5, can't type, 8.5, nailed it. Okay, 2.5, 3.2, 2.8. Okay, and then next column for list 2, 1.6, 1.7, 2.4, 1.9. Notice that the points are not necessarily in any sort of order, but you have to make sure that the X and Y or list 1, list 2 is matched up properly. So triple check that everything's good there. So now I'm gonna read finally. Okay, so if I read the problem, it says that the number of hours that someone watches of television is represented by H, and then the number of books that they read is represented by B. But look at how this is set up, capital B, by the way. The B is set up as correlating to the Y value, which is like our output function value. And then the H right here is correlating to what we would normally consider to be like the X value. So it looks to me like this is kind of inverted. So this is supposed to be my X and this is supposed to be my Y. It's a darn shame that I don't like read before I type things. So do I curse and say, oh, I gotta retype everything? No, I don't. Because remember when we go to that calculation screen, your calculator is going to ask you who is the input and output of your function. So if I go to Stat, and I go over to Calc, and I go to Linear Regression, so where it says X list, Y list, I'm just going to flip them around. So I'm going to say X list is list 2, and then Y list is list 1, and then I'm going to calculate, and now I'm good to go. So slope is negative 1.61 if I round, and then y-intercept is 6.28 if I round. Correlation coefficient, remember, is the second r, the square root of the r squared. It's negative 0.98695, blah, blah, blah. Okay, so good. It's negative, but it's a very strong correlation. So the question is, the first one said which is list 1 and list 2. That was like the other teacher being super nice to you and making sure that you had the right input and output. And the equation was negative 1.6. I don't know if it said where to round. So let's just go, for the sake of writing, let's just go to the hundredth place. 61x plus 6.28. And then it says if the linear model is valid, which it is because it's strong negative correlation, would a person be watching, how many hours would of television would a person be watching if they didn't read any book? Well, that's a shame. You should really read books, guys. So remember, the number of books is y. So if I go to this function and I put a y instead of 0 and I try to solve it, first I would add the 1.61x over equals 6.28, and then I divide, and it comes out to like right around 4 hours of TV. Excuse me. So the correlation coefficient, I didn't write that down, is negative 0.987, I think. If it wasn't, I apologize. That's a very strong negative correlation. So model is good. Model is good. All right, the follow-up question here has you doing more of the same thing. So again, same steps on the calculator. They want our model to start in 1994, so this is going to be considered 0 in the table. So 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. You're going to list the consumption of gallon. What are we? Gasoline. Okay. In the other list, and then you're going to set up your stat calc linear regression. Make sure that the lists are appropriate. So the year should be, if you put it in list 1, that's going to be your X, and this will be your Y. And then if you do the correlation calculation, please pause now if you're typing. I can't be quiet that long, so just pausing. Okay, and we're back, and our correlation coefficient came out to, oh man, I didn't write it down. Sorry. Okay, well hopefully you know, because I didn't write it down. But the equation is 2.209x plus 113.318. I don't know. I don't have that in my calculator. Sorry. And then predict the consumption in 2008. So I would use the model that you just came up with. That's the best way to do it. And it approximates to 144.25 billion gallons of gas. Ugh, that handwriting, awful. All right, so sorry, apologies on that correlation coefficient. I mean, hey, if they asked me to use the model, it must have been pretty decent, right? I don't know. All right, so using your calculator might be a new experience for some of you. We just have to kind of keep with it. All that muscle memory that you talk about when you learn a sport, it goes into math as well, especially when we're utilizing our technology. So don't give up and keep on top of it. Ask questions when you need.